Hey everybody, just wanted to give a quick explanation of some of the practice problems for the Cumulative Review 3. And these problems align with the Cumulative Review. In problem 1, we had to factor, and so since there's three terms there, a trinomial, we would AC factor, and the factors, you want to find factors of A times C, which would add up to the B. Those factors worked out to be -3 and 8. And then once you find those factors, remember that you always want to divide by the A value, which in this case was 1, and simplify. But since it doesn't simplify here, then you can just apply the X, slide it to the front, and you get these two expressions. Problem 2 is the same thing, AC factoring, but this time A was not 1, A was a 3. So once we found our factors, we divide by 3 and simplify. This one did not simplify, so it was ready to slide. But this one did simplify. 3 divided by 3. You don't want to use 1. You want to use 1 over 1 because you want to have a denominator to slide out to the front. And so once we simplified it, we slide and we came up with these two expressions. Problems 3 and 4. Problem 3 is also factoring, but it's dots factoring. Difference of two perfect squares. That's where we want to square root each term. Remember that dots means difference as in subtraction, so you don't want to do this when there's addition there. Okay, so square root each term. Square root of 25 is 5. Square root of x squared is x. And the square root of 49 is 7. Remember to use your plus minus in the middle so that when you break up the expressions, one gets a plus sign and the other gets the minus sign. Problem 4. Finding the solutions. This is one where you can just graph it in Desmos and see where the lines are going to cross the x-axis. Basically like finding your zeros. Or you could use the quadratic formula if you wanted to. Either way, it's going to work out. And we'll do one more. Problem 5. Okay, problem 5 is two parts, question A, question B. You have an object that starts on a platform 10 feet above the ground, and then it's launched into the air, and this is the expression that would model that. First question says, what's the object's maximum height? That's a vertex question. That's where you can graph this in Desmos and then just click on the vertex, the location of the vertex, and it will give you two values. Remember that those values are x and y, or in this case, a t and an h. The time it takes to get to the vertex and the actual height of that location. This one of the maximum height, so you're looking for that y value, the 154. When will the object hit the ground? Remember that hitting the ground is like hitting the x-axis. It's like finding the zeros. So again, you graph it in Desmos, click on the location where it hits the ground, not the first location, because that would be where, you know, it was coming off the ground, or it would be a negative value, and we don't use negative values when it comes to time. So you're looking for that second location, the second x-intercept, and that came out to be 6.102, or basically about 6 seconds.